you sick of manually injecting samples into your HPLC instrument? Tired of having sore arms and poor resolution between peaks? Yeah. Well, we have the instrument for you. The Agilent Auto-Injector HPLC with gradient elution capabilities will save your arms and your lab results. So for the very low price of $19,999.99, you can have this. So call 555-CHEM today. That's 555-4752.
All right.
Still not convinced? Wondering why you should spend $19,999.99 on an HPLC auto-injector? Well, I'm here to tell you why. There are many benefits to auto-injectors, which make them very popular today in analytical chemistry labs. First of all, you get more precision with injections. Second of all, you get a lot more output of your sample. And last of all, you can run up to 100 samples unattended, which decreases the amount of manual labor and saves you risks from carpal tunnel.
Here is the auto-injector HPLC instrument. You can see here at the top that there are two bottles for the two different mobile phases we use in gradient elution. Here are the two different pumps that are used to combine the two mobile phases. And down here is the place, the sample receptacle, where samples are picked up by the robotic arm and moved for injection. Over here is the actual HPLC column.
You can see here the software for the gradient elution. On the left are the two solvents, water and acetonitrile, which are the two bottles resting on the instrument. On the right is a timetable showing the relative percentages of the two solvents. In this case, the experiment starts with 95% water and 5% acetonitrile, and then decreases to 90% water after 5 minutes, then to 70% water at 15 minutes. If we have one compound that elutes very quickly at 95% water, and another that elutes quickly at 70% water, the peaks for these two compounds will differ by roughly 15 minutes, giving very good resolution. This is the primary advantage of gradient elution over isocratic elution. Here's an example of two plots where gradient elution gives much better resolution than isocratic elution. On the bottom, we see there's good separation between all the peaks except paracetamol and caffeine. But when we use gradient elution, the caffeine and paracetamol peaks are very well resolved. And this is because the gradient of solvents causes the caffeine to start to accelerate through the column sooner than the paracetamol, and thus we get two distinct peaks. The greater resolution that gradient elution offers means that it would have been useful to use in the mysterious death lab, where the peaks of one of our compounds was strongly overlapping with a solvent peak. So that wouldn't have been an issue if we were able to use this instrument with the higher resolution as we saw in this graph.
We will now have a short break in production for an example of the auto-sampler function of the HPLC system. We can program the arm to grab our exact sample and place it within the needle seat. The needle will then puncture the top of the vial and go into our sample. The withdrawal of the specific volume of sample is controlled by the metering device. When this is done, the needle is withdrawn and the arm will grab our vial and place it back into its original position. The needle will now form a closed loop with the needle seat. The motor will rotate and create a new loop where the red mobile phase pushes our green sample into the column. As it is pumped out, the sample will finish and it will revert back to its original shape. The rotation will close the loop and the needle will be withdrawn from the needle seat to finish the sample. This is an important example of the auto-injector function as it eliminates the need to flush the syringe after the sampling. This is due to the fact that only mobile phase is in the loop and it does not need to have any sample cleaned out of the needle.
There are many varieties of autosamplers, each of which has specific advantages and disadvantages and may be more useful in certain situations. One type of autosampler is called a pull-to-fill autosampler. Some of the advantages of the pull-to-fill autosampler are its simple design and reliability. It is also quite inexpensive and has very few maintenance costs. Some disadvantages, however, are that there is no flushing procedure, so you have to put wash vials between each sample on the carousel. Additionally, there is a substantial loss of sample during the injection, potentially up to 10 to 100 microliters of sample for each injection. Lastly, it has a very simple design, so all samples may need to have the same number of injections and the samples have to be put in the correct injection order. Another type of autosampler is the push-to-fill autosampler. One of its advantages is random access to vials and a variable number of injections and volume for different vials. And it can also inject a wide range of different volumes and has a low-pressure seal that can be adjusted easily. It is more mechanically complex, however, and it thus has more issues that need to be repaired. It has less sample waste than the pull-to-fill autoinjector, but more than the integral loop autosampler. Lastly, we have the integral loop autosampler. Some of its advantages are random access to vials and a variable number of injections and a different volume for vials. It also has minimal to no waste and is thus very good for trace analysis experiments. Lastly, it has mobile phase flushing, which leads to less contamination and carryover, which is something that we saw in Lab 11 and would have helped to clean up our graphs. Some disadvantages are the more restricted upper range of injection volumes and the high pressure seal, which needs to be checked quite often. It also has a very complex design, so it's harder to diagnose mechanical problems and often more expensive to repair.
So now you know all there is to know about HPLC. So how is it used in the real world? Well, there are many applications, and today I'm going to talk about 3 of them. First of all, HPLC is a critical instrument in the field of pharmaceutical industries. Since 1980s, they have been using HPLC to test for their product and to see its purity. HPLC provides a method of high accuracy and selectivity. HPLCs are also being used by the U.S. Food and Drug Administration. FDA uses this method to test for their products before they approve it to be sold in the global market. There are even books out about how to apply HPLC to analyze food additives, contaminants, etc. Finally, HPLC plays a major role in forensics, as it is their primary method of analysis. For example, HPLC can be used to investigate confiscated drugs to find out where they're from. It can classify car paints after car accidents. And it can also be used to find evidence of substances such as poison, which is similar to what we did in our mysterious death lab.